addicts here. Um, I'm just gonna get you a hands up for what I'm expecting from comments. What I'm expecting from comments is that you should not be talking about my family. You should not be inviting people to my live. I should not be able to invite people to my live. Well, I am gonna invite my people from around the world. Okay, never mind. So I'm not gonna be able to show anyone in here. Okay. Okay. So here's the original live. So today, me and my Algebra 1 people are going to be learning about exponential functions. Okay. So, exponential functions. There are 10 things that we are going to discuss. We're going to go over the first 3 together as a class. And then the next time that I teach, we're going to go over 4 more. And then the other one, I'm going to do 3 more. Technically, I'm supposed to be doing 2 live streams because I'm supposed to be getting ready for my future 9th graders for their original forecasting for classes. But I'll be able to make some lives. Okay, I'm planning on doing a live stream of first period at 8. Then second at 9:02. Fourth period at 1:46. And then period 5 at 2:50. Okay? So that's gonna be my schedule for tomorrow. Okay. So today, let's discuss exponential functions. So what are exponential functions? Well, exponential functions are a type of function. Oh, sorry. Well, hi. Okay. So, okay. Before we start, are there any questions? That does not involve my family or whatever. I'll change my subscriber count because it has been at 200 since this morning. Now, speaking of which, thanks for 200 subscribers. No? Okay, let's go over. So, okay. So, this is 6-3. Exponential functions. Okay. Are you all ready? Okay. So we're going to start us off with graph and properties. So this leads us to the first 3 sections. There are 10 sections in this lesson, probably. But the rest of the sections are going to be coming from my big ideas packet from 6364, which, never mind. Okay, so graph and properties is section 1. If this goes quick, I'll add a couple, just in case. So graph and properties. Oh. Okay. So. Huh? Oh, man. Hi, Thomas Sarango. Okay. Okay. So. Okay. Okay. So we. Okay. So one of the term, or one of the variables, A is the initial value. Which is the y-intercept. And can be any real number. Positive numbers, negative numbers, maybe decimals. I don't know. Okay, we have cutie and cutie. Oh my goodness, I did not even expect that. Hi. Hi. Okay, so B is the base of a number of a power, my bad. B is greater than 0, always. So why is B greater than 0? Why can't it be negative? Because negative numbers are smaller than 0. And positive numbers are bigger than 0. So, me, Nash, 3042, me. Hi. Okay, so I think we have more. Okay, so X. Okay, so we're going to represent what a linear function is compared to an exponential function. So this is section 1 step. So if we take two tables, yeah, they kind of look like Christ signs. Sorry, but okay. So X, and now we have a Y. Same thing here. Okay, so X is the exponent, and Y is just a number. Okay. So, okay, so the whole thing multiplies by 2. Well, no, multiplies itself twice. So, okay, so let's take a look at what linear functions are. So let's take negative O. We have negative 3, negative 2, negative 1, 0, 1, 2, 3. We're going to do the same thing to the other side. Negative 3, negative 2, negative 1, 0, 1, 2, 3. And now we're going to do the same thing to the y's. But y's, for this one is going to be the linear function. This one's going to be the exponential. So let's take a look. Okay, so let's do negative 7. Maybe we could add, maybe we could subtract. So let's do adding. So we do negative 5, negative 3, negative 1, 1, 3, 5. But for here, it is 0.125, 0.25, 0.5, then we have 1, and 2, and 4, and 8. See the pattern? The graphs are going to be different, okay? The graphs are going to be different. So, okay. Okay, nothing so far. So, I don't know how we're already 11 minutes through the thing. So, this, we have a pattern. We're going to do this with purples. So, this adds by 1. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. And then we have this. Add 2, add 2, add 2, add 2. So this will be plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. And then we would have more. Okay, so this will be a linear function. Linear functions are kind of a little bit simple, but you need to like graph them, everything. So we're just gonna graph when we're done completing the table. So see how this one adds by 1? So it's the same. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. But we have times 2, times 2, times 2, times 2, times 2, times 2. Okay, so if x will be 4, then what would be y? 16. So, speaking of which, when it multiplies by 2, we would get an exponential function. But the y, but the x's would have to be the same thing. So, okay, so right is an exponential function. Okay. So now I'm going to show you the graphs. Okay. Yeah, we would keep the title and the section number. So we would make a giant graph. This point is always 0, 0. So 0, 0. Why would it be 0, 0? Well, the x-axis and the y-axis touches each other. So vertical, like left and right, it'll be the x-axis, and up and down will be the y-axis. So why wouldn't it be 0, 0 if it were for functions? So let's do the exponent functions. So before we do that, I'm going to label every number on here from 1 to 10. So that's all that we really have to do for now. So let's now plot the lines. But before we get to that, we need to know the table. So as far as I'm concerned, I'm going to move my pen fan here. Actually, I'll just turn it on a little bit. Okay. So, can you guys see down here? It's great. So, okay. So, let me get my blues and reds. So, exponential functions. We got -3, -2, -1, 0, 1, 2, and 3. For the y-axis, we get 0.125, 0.25, 0.5, 1, 2, 4, 8. Okay, so it gets from a smaller number, and then it gets to big, and then a big, and then a big, and big, big. All the way up to just infinity. Alright. Okay, 8 people watching. Okay, good. Okay. So, we're gonna plot the lines now. So, 0, 1. So, 0, 1 on a line is always this point. So, 0, 1. We get 1, 2. Wait, 1/2. So, we connect the line. And then, wait, I don't think that's right. So I'm just going to erase this, and then rewrite it again. I do not want the lines up here. Okay. Yeah, not missing up. So, vertical, diagonal. So, here is 0, 1. Here's 1, 2. 1, 1/2. And then we have okay. So we're going backwards for a little bit. So -2, 1/4. And then we have 1/8. You see that tiny dot? That tiny dot? It's so great. So now we're gonna move up 2, 4. Wait, no. We're already at 0, 1. So now we're at 1, 2. And then 2, 4. And then 3, 8. Okay, so now let's connect the dots. Okay. That's what an exponent function looks like. So, this is also, okay, so here is the formula for this. Okay, so, this is f of x equals 1. Oh, I'm just going to write it down. So, f of x equals 1, 2, x equals 2, x. See? So why do we multiply stuff by 2? 21 minutes, 25 seconds. Okay. Yeah, still then don't see any comments here. Okay. Okay. Any more? Nope. Okay. So we're already at 207 subscribers. Already. So please subscribe. I need to get to 250. And speaking of which, I'm already going to be hosting my 200 subscriber party. And my hairs are probably setting up. Okay. So, thank you all for watching this. This is not the end. This is not the end of a thing. We need to get to 2 more sections before we end this. Okay? Thank you. So, let's continue. Okay. Okay. So, why is this called an exponent function? Okay. Thank you. Okay. So. Okay. Are you ready to move on to the next section? Okay. Okay. So here is what we're doing. Okay, so it says the horizontal asymptote. So what is horizontal asymptote? Turn and talk to your neighbor. What do you think horizontal asymptote is? Talk for like 1 or 2 minutes. Like I said, go. Okay, no more. No comments? No. Okay. Okay, already have 25 minutes. Okay. Okay, thank you. That's all of the discussions for today. So what time is it? It's normally 10:16. Okay. So you have about an hour and 10 minutes left till the bell rings for lunch. Okay. Class, I have some news. Yeah, I'm not going to be able to teach you all tomorrow because we're going to be forecasting for classes for next school year. So, thank you. Okay, as you see here, we have domain, which is equal to, which is negative infinity, which is at the very bottom of the line, to positive infinity, like to the very top of the line. So, like, we have when x is goes to negative infinity. 2 to the power of x is equal to 0. Well, not true. What's 2 to the power of 1? 2. What's 2 to the power of 2? 4. What's 2 to the power of 3? What's 2 to the power of 4? See? We got all of these problems. So we have all of these things that we're going to be going over for the next year and a half. Oh. Prashantarya. Hi. Okay. So, if you think that a horizontal asymptote is like, oh, would it be confusing to you in any way? Raise your hand. Okay. So, graph properties. Okay, so we're almost at the second section. So, the range is from 0 all the way to the positive infinity line. So, where I'm standing right now, to the very top of the earth. Ah, great. The domain is from the very bottom of the earth to the top of the earth. Negative infinity to infinity. Yeah, what I call to the bottom of the earth is what I call negative infinity, and what I call say to the top of the earth, I mean positive infinity. Like where I'm standing is 0. So let's move on to the second section. Oh wait, I kind of forgot. Yeah, I forgot to tell you about linear functions. Linear functions are like linear functions are straight lines. Like if you say 1/3 x plus 9, you go to the positive 9, and then you do this. Or maybe this, according to you. Okay? So, let's move on to the second session. Growth versus decay is the second section. Section that we're going over today. Growth versus decay. Well, growth versus... Okay, so this video will talk about what we're going to be learning in lesson 6.3 and in lesson 6.4. So, I already have 4 likes on my video. Thank you. So, let's continue. Growth versus decay. Okay, so this is a must know. So what is growth? And what is decay? Well, we have exponent growth, and we have exponent decay. Everyone write this in your notes. Not the people that are watching. Sorry. Okay, so we have... Ugh. Huh? Oh. I see little emojis at the bottom. Thank you. Exponent growth. We have exponent decay. Well, first off, as it being growth, as in growth, you all mean in general, but you like growing up, but in decay, I don't know. So what do you think exponential growth is? turn and talk to your neighbor for a little bit. Ready, set, go. Okay. Now I see little emojis flying out. Thank you. So, okay. Okay. Okay, that's it. Thank you. So, exponent growth versus exponent decay. So, what do we mean by what exponent growth versus by exponent decay? Okay, so we have. Wait, what? Sarah, hold on. 273. Come over here. What the? Yes? Wait, never mind. Wait, never mind. Okay, so, speaking of which, exponent growth. Okay. So, here, as x increases, then y decreases, then y increases. Okay, so if a is greater than 0, b is greater than 1. I think b is greater, no, not greater, less than 0, I think. Okay. So, speaking of which, 23 minutes, okay. So we have here 2 graphs, 2 tiny graphs. So this is when a is greater than 0, b is greater than 1, and then this is when a is less than 0. I don't remember what my a is with a loop over. But decay. So as x increases, then what happens to y? Decreases. Correct. So as x increases, then y decreases. Okay, so here we go again. 2 graphs. Okay, so we have here, and then we have here. Okay. So okay. So here's a little bit of a challenge for you. All for the next 5 minutes. So if you start with 1 cent and it doubles every day, how much will you have after 30 days? Turn and talk to your neighbor. What would happen if you have a penny, a simple penny, and it doubles every day? It's like it will get to 2 cents, 4 cents, 8 cents, 16 cents, 32 cents, 64 cents, $1.28. You know, it could double every day. It could be a lot. Turn and talk to your neighbor. Ready, set, go. Oh, shoot, yeah. And also, I'm gonna write the word problem up here. 3 minutes to discuss to your partner. Okay, class. So you have 1 more minute left to discuss to your partner about this question on the board. Okay, class, enough talking about it. So let's discuss. So, what if you take 1 penny and you double it every day? How much would you have? So, we would have y equals a, then b, and then x. So you will have 0.01, which is the a, and then you plug in b, which is 2, and then you have 30. But exactly, how much would you have in a week? So let's start with day 1. So day 1, you have 1 penny. You have 1 cent. You're very homeless. But in a month, you'll be a millionaire. So you'll do 0.2, then 0.4, then 0.8, and then 0.16, then 0.32, then 0.64. Okay, so you earn $64 in a week. So then on day 8, you have $1.28, then $2.56, then $5.12, then $10.24, then $20.48, then $40.96, and then $81.92. By week 2, you have finished with $81.92. So now you would combine with 163.84. So 81.92 times 2. $163.84. And then you end up with $327 and what's it called? 68 cents. Then you have $655.36. We have 1.31072 thousand dollars. So we have 1310.72. Then you have 2621.44. Then you have 524.288. 2.88. Then you have $10,486. And I start adding them up. And then when you add 0.01 times 2 to the power of 30, you would reach 10,737,418.24. That's incredible when you are becoming a millionaire. Okay, so like you add $30 in your bank account. And when you add another 60 in your bank account, and then 120, and then 240, and then 5, whatever. So, let's do the cake. 44 minutes? Okay, God. Okay, so. Okay, so it says U-239 has a half-life of 2 years. How much of a 1,000 milligram sample will be left after 10 years? This is starting to get quicker and quicker and quicker. Now we're at 45 minutes. So let's move on to the thing. Okay, so here's what you have. Okay, so you have A, which equals 1,000. Then you have B, which equals to 1/2. Then you have X, so equal to 10 over 2, which is half-life. Ten was there because total time. The total time is 10 years. Well, 10 years. The half time is 2 years. What's 10 divided by 2? 5. So, we would have X equals 5. But we're not even in the problem yet. How could we be done if X would equal 5? So, we're going to have Y equals A, then B, and then X. Then we have Y equals 1,000, 1/2 to the power of 5. Then what would you have? 1/2 to the power of 5. We will have 1 over 32. So we will have 1,000 times 1 over 32. What would that equal? Maybe we would multiply 1 over 32 by 1,000. And it just gave me a fraction of 125 divided by 4. So, which means 125 divided by 4 31.25. This is how many samples of 1,000 milligrams, which is 1 gram, maybe. So, that's it for the second thing. Now, since we're already at 48 minutes, let's move on to another one. We have one more section to go through. And this might be quick. Yeah, this is the quickest out of all of them. So, section 3. Equation from graph. So this is our third technical lesson. So, it goes all... Okay, so... Okay, so we have y equals a, b, x. Take a look at this graph for a moment. What can you learn from this? I'll write down a point to help you out. 0.55 and then 110. What can you learn from these 2 points in the graph? What would you equal? Turn the top team in. Ready? Sorry. Go. 50 minutes, guys. We're already at 50 minutes of this live stream. Okay? Okay. So, what time is it? It is 10:41. Okay, class, you know I'm talking about it. So, okay. Yeah, we're finding the slope. Okay, so we're already halfway through the section already. So we're already at 5 equals A, then B, then 0.5, and then we will have 10 equals A, B, 1. Okay, step 2. We will do 5, we would solve for A. So 5 divided by B, 0.5 equals A. So now we're going to plug this in. to this equation here. So we have 10 equals and we have 5 divided by b of 05, 0.5 times b 1. And now we look at 10 equals 5 times b 0.5. And then we would put 2 equals b 0.5. 2. How would we get 2? Okay. 2 squared is 4, and that is b. So, okay. Oh, there's more. So, here's a little bit more that I might surprise you all with. Here. But we're going to leave that work there. So, we're going to do 5. Okay, so we're going to plug this in. Okay, so I have 5, and then b over 5 equals a. And then we have 5 divided by 4 over 5 equals a. And then we have a equals 5 over 2 or 2.5. So y equals 2.5 times 4x. No matter what x equals. So, here's what I'm going to have you do, class. We're done for today with exponential functions. So, if you have any questions, talk to me. I'll be there to help. But for the class, thanks for watching. Make sure to like, make sure to subscribe, make sure to comment if you are confused on anything. Okay? I'll be there to help. Like and subscribe.